What's the time here? I said about 5 minutes. Yeah, 5 minutes. We're at 108 degrees on the main control box, and our voltage is. You want to hold the camera there? 23.4 volts. 23.4 volts. All right. Well, pause things here for a bit, and then take a look here in another 5-10 minutes. Well, it's keeping the speed up pretty good so far. We're going to run this until the batteries run down sufficiently. We're going to watch the temperature here every 5 minutes. We're out here on the roof of Florida Microelectronics, as you can see. Oh, it's getting hot up in the lovely town of Mangonia. All right, so we'll see how this plays out. So far, so good. The objective here was to run this thing without a heat sink on it. Obviously, that would be, if this runs without a heat sink, then we're really ahead of the game here on this one. So let's keep our fingers crossed. Obviously, we have to test this at temperatures between 95 degrees, because in reality, that's what this thing will be operated at in various tropical locations. Yesterday, Jose ran the tests in an intermittent mode with it turning off and shutting off automatically. That was important because of the large transient, both voltage and current spikes you get when the unit turns on and off. We want to determine that there's, and we actually detected spikes in the order of 200 amps in this. So you could imagine, and we got fairly significant heating in our snubber capacitor, which we crimped to keep the terminals from melting. But that, you figure I squared R and something like that, you're looking at an enormous amount of heat. But that's the nature of pulse width modulation, is that you're switching that current, and you get the reverse EMF and the large current spikes. So, which is probably what was killing those Kelly controllers, now that we're actually able to measure it. Okay, it's 10 minutes, almost 11 minutes. We're taking a fresh measurement here. We're going to check the voltage as well as the temperature. What are we getting there, Jose?
130.
130. That seems to be the operating temperature this gets up to, what it did last time. The question is, if we're doing this without a heat sink and it stays in and around that temperature, then that'll be pretty good. Let me see what I'm going to hold the camera here. Let me check the voltage. 22.4 volts. Okay, 22.4 volts it is. All right, we're taking another measurement. We're at about, 15 minutes, okay? 20 minutes in. All right, so 135 degrees. The compressor is a good 220, 230 degrees, which is what we'd expect. The motor isn't that hot yet, but so far so good. Well, you can see, you can listen to the motor, you can hear this slowed down. We've been running about 25 minutes, and the voltage is way below what the cutoff should probably be, 16 volts. But in theory, we're going to just let this go to until it shuts off, until the batteries are completely gone, just for the purposes of testing. In practice, we wouldn't do this. Well, we've run the battery voltage down to less than 12 volts, so I don't think these batteries were fully charged, or else they're old. But we're going to need to run this with a more robust power supply. So I think we're just going to shut it off now, because in practice, we would never run this at this voltage. We need to keep the voltage up around 21 volts. Now, when we have the large lead-acid batteries, this isn't a problem. So anyhow, we're going to, we run over half an hour, still running. We're going to, if we were going to cut this thing off at 21 volts, it would have cut off some time ago, before we're even 20 minutes into this. So we're going to shut it off now. Okay.